Danny.
So 26 is DNA. Why not DNA?
All right, so again, when I see that distinct triangular darts, I'm looking at law signs for the ambiguous case. So yeah, I'm gonna draw a picture first. So probably the biggest thing though is to remember when you see distinct triangles and you think of law signs, and you've got the bad word, that SSA, you go through the law signs, you get your first degree to be 49, plug it into your triangle. 49 30 is going to be less than 180, so you've got one triangle. Take your 49, subtract it from 180 because sign is positive and quadrants 1 and 2. Maybe another option is 131. Sure enough, 131 plus 30 is still less than 180, so we can keep moving forward. Take those handy dandy formula sheets out. Today's a big day. I'm going to double angles. Going double angles. Double angles are going to be big on your Regents exam. In fact, in calc last period, I threw off a double angle and boom, ran it right out of them. I said, what's different about here? She goes, oh, we got double angle. So we haven't done traits since last year. You don't do much trait in your talk. And I was impressed that she recognized that. Okay, so we've got double angles on our formula sheet. How do we recognize a double angle? Here, sine 2 theta, 2 times the angle, so it's a double angle, versus 2 times sine theta. This is a single angle, theta. This right here, 2 theta represents your double angle. That's a clue to you that, oh, I'm not using single angles anymore, I'm using double angles. So everything over here on the left are double angles, and everything on the right are single angles. So you can see we're doubling the angle versus doubling the answer to the cosine of the angle. So that's the first thing. Go to your formula sheet, please. And you're going to see the functions of the double angle, top right hand side. So I see functions of the double angle. Look at cosine. How many choices do you have for cosine of the double angle? 3. Generally on your Regents, that's what they're going to give you, is something involving cosine of the double angle, because they want to see if you can figure out what to do with it. We're going to use double angles. Earlier in chapter 14, we went through and did proofs with single angles, proved left side equals right side. And then we went through and did trig equations with single angles, just finding the answer. Well, guess what? We're going to do the same things all over again, this time with double angles. All over. You have we have a schedule change tomorrow. Originally it was going to be periods 1 through 6, and yesterday they changed it to periods 7, 8, 9, 4, 5, 6. So I still see you guys requested your quiz to be Friday. So I will put double angle proofs on, but not double angle equations. And I'll work on that tonight. That's exactly what's on tomorrow. Alright, so let's keep moving on. Alright, here we go. Formula sheet. We're going to prove that the cosine of the double angle is equal to 1 minus tan squared all over 1 plus tan squared. So let me just recap for our absent students what we did and give Ian that credit that he deserves, because that was just awesome. So we realized that our denominator, 1 plus tan squared theta, is equivalent to secant squared theta, so we subbed it in. Then we figured we had to go to deal with tangent squared or sine squared over cosine, so we subbed that in. Then Ian said, hey, let's take our secant squared theta, write it as 1 over cosine squared theta, so that we can multiply everything by our LCD, and we get cosine squared theta minus sine squared theta. We went to our formula sheet. That's one of the 3 cosine of the double angles, and that's what we had to prove. That was awesome. Ian, that was great. I think I was going to take this way farther doing it my way.
Yep.
Nice job. If we're looking at this one, which side are we going to need to leave alone?
The right side.
Yeah, we're going to leave the right side alone because it's clearly easier. And do you notice anything on the left side?
The double angle.
Thank you. See, we have a double angle in our numerator. So the first thing we have to do is deal with the double angle before we do anything else. So go to your formula sheet. What is the sine of the double angle equal to? So once we reduced the 2 over 2 and assign in the numerator with one of the signs in the denominator, we were left with cosine x over sine x, cotan x. Therefore, I'm not going to write the original. The original problem is okay. The identities are easy enough that I want to get into the equations. I'm going to spend today and tomorrow on equations, but I'm not putting these on your quiz. Right. They'll go on your test. Annie.
If we had more like a double angle that we had to change for cosine, how would we know which one to put in for?
We're going to practice that today. Oh, sometimes it's obvious. For example, if we do an equation today, and let's say we had cosine of 2x minus sine x, you don't want to, you only want to, you want one trig equation, so I'm going to go to the one that has only sine in it. If I have a cotan or a tan in there, I might do one that has sine and cosine because I know I can manipulate those. Sometimes it's guess and check. Sometimes it's try to make sure you have one trig equation. But we're going to do that today and tomorrow. Good question though. Okay. So we're going to work in radians or degrees. Radians. Can we use 360?
No.
No. And we look at our trig function. Do we have any double angles?
Yes.
Yeah. So the first thing we have to do is get rid of that double angle. Luckily, it's just the sine. So go to your formula sheets. What's it equal to?
2 sine x cosine.
I'm going to sub that in. Rewrite the rest of my equation. And do we have a linear equation or a quadratic equation?
Looks linear.
It is linear because all the powers are 1. Good. What would you like to do next?
Factor out the sine.
Perfect. Let's factor out a sine x. What does that leave us with?
2 cosine x
Uh-huh.
minus 1.
Good. Yeah, don't forget that minus 1. If it was a binomial and we pulled something out, it still stays a binomial. What do you remember doing next?
Set both sides equal to 0.
Perfect. Take your factors. Set them equal to 0. Sine x equals 0. Cosine x. What do we do now?
Sine x equals check all the
Yeah, we're going to run the unit circle over here, you're right. But remember, what are we going to do over here? Okay, so we'll solve. We'll add 1. 2 cosine x. Now we're going to take that next here. Cosine x equals half. And what do we do now?
All students.
Nice. All students take calculus. Cosine is positive in which quadrants?
Where's
1 and 4. Great. Okay. Since we're already working there with cosine, why don't we work that? So we're going to take our calculators, make sure we're in degree mode. Unless you want to work in radians, that's okay. We're going to do second cosine half. Did you get 60 degrees? So that happens to be one of our answers, but we have to put it in radians. So 60 is pi over 3. Off to the side, we got 60 degrees. To get to quadrant 4, we're going to subtract it from 360. So 300 degrees. So you can do the conversion, or I know that this is 2 pi. So if I take 2 pi and minus pi over 3, that's going to be 6 pi over 3, getting down to minus pi over 3, 5 pi over 3. But if you want to go and convert 300 degrees times pi over 180, that's fine. Then Danny said for the left side, we're just gonna test 0, 90, 180, 270, but not 360. And we're gonna look for when sine is 0, because this is a quadrantal. So we'll start with 0, sine is 0, works. So that's one answer. Sine at 90, does not work. Sine at 180 is an answer. That's 5. Sine 270 does not. Oh, I was gonna say that's wrong. Sine 270 does not work. We can't test 360. So we actually have 4 answers for our linear trig equation. Nice. So I'll put that one up there. So I'm going to put my double angle in parentheses because I'm multiplying by 2. Now I got to figure out, I've got 3 choices for cosine. I'm going to look to my other term. This term only has cosine in it. So I'm going to go to my formula sheet and I'm going to look for a cosine of a double angle that involves only cosine. Which one is it? Second one. So instead of cosine 2a, I'm going to plug in 2 cosine squared. I have to use theta minus 1. That's the second one. Only cosine there. And all I do is sub for the double angle. Now I'm going to rewrite the whole rest of my equation. Once I sub in, now I can start working like we've always worked. Alright, so we distribute it. We recognize the quadratic equation. Brought the 1 over, put it in standard form. You want to use a quadratic formula or you want to factor? You know how we try factoring. There are going to be times that you're going to have to use a quadratic formula. And we'll address that, but let's see if we can't factor. Let's check this out. So I've got 4 cosine squared theta plus 4 cosine theta by 4 minus cosine theta. So 4 cosine minus 1 cosine is positive 3. And then my last term gives me that negative 1. Just always remember to check those last terms as well. I'll let you finish from here. I'll keep going through it. So if I work cosine theta equals negative 1, that's a quadrantal because it's on the unit circle. So I'm just going to run that unit circle. So I'm going to check cosine 0. That's not negative 1. I'm going to check cosine 90. That's not negative 1. I'm going to check cosine 180. That's negative 1. So theta is are we in radians?
Yep.
Yeah. So that's going to be pi. If I check cosine 270, that's not negative 1, and I can't use 360. So now let's go to the other side. Here we're in quadrants 1 and 4. So I'm going to go second cosine 0.25. Oh yeah, that fight you said. What about those Nancy decimals? So let's take this. I'm going to take the second angle.
Oh, you did.
It's still nasty.
The degrees. So 78 degrees is 27 minutes. So you know what? Let's go to the nearest degree, just to make life easy for us. So our answer is going to be 78 degrees. This is off on my scrap.
That's for 0.2, not 0.25 though.
Oh, did I fix it?
Yeah.
Oh, thanks. Second cosine 0.25. So 75.5. So that's going to round it up, isn't it? Yes. So 75 degrees, 31 minutes. So we're going to take that to 76 degrees.
Then we got to convert that to radian.
Yep. Because we're moving a minute. So scrap is 76 degrees. So to convert that to radians, we're going to multiply by pi over 180. Just take handy dandy calculators to reduce it. You get 19 over 45 pi. So that's one of our answers. Then to get to quadrant 4, what do we have to do? Yep, so I'm going to take 360 and subtract that 76 to get 284. And then I'm going to multiply that by pi over 180, convert it to radians. 284 divided by 180. And did you get 71 pi over 45?
If they give us a question with this, should you round to degrees and then convert it to radians? Or should you like keep the decimal?
Should probably, if, I don't think they would ever give that to you. If they do, I'd keep everything round at the very end. Let me give you your homework, because we're short on time. Remember, double angles, not on your quiz. I'll work on your quiz tonight and tell you exactly what's happening.
So for homework, keep it nice and simple. We'll do page 824. And I'd like you to do number 12. That's working with half angles. It's a good review for your quiz. 34 and 42. 34 and 42 use your double angles. This is, yeah.